Hello everyone. We are on lesson 7.7 today, trig values of any angle. So here's the scenario. You're going to be given a point on the coordinate plane and you'll be finding any trig value, any of the 6, created by connecting that point to the origin. So here I have a diagram that kind of explains that. So you're just given a random xy point. I plotted it here. Of course it could be in any of the 4 quadrants, it doesn't matter. When you connect that point to the origin, it creates an angle. Now the interesting thing about trig and the way that works is that pretty much when you drop the reference angle from there, remember the reference angle is this acute angle, it creates a triangle. And so you can use that triangle to find the 6 trig values of this angle. As long as you use these numbers, that will give you the same trig values as though you were finding that angle. So even though the angle in question is this one, the one that connects to the x-axis, the reference angle answers are the same. So, wow, that's a sloppy, messy drawing. So you're going to be given a point. Here, let's look at some of the assignments. And this part of the diagram is already done for you. And you're basically going to connect that point to the origin, which makes a right triangle. And then as you know, for right triangles, you can find trig values, sine, cosine, tangent, secant, whatever. Now these angles are all, for some reason, rotated in this direction, but it really doesn't matter. It just doesn't matter at all. The values you find will be your answers. Now before I get down to those, you see that I have some other notes here. So we know that with right triangles you can do the Pythagorean theorem. Here I'll label that PT for Pythagorean theorem. A squared plus B squared equals C squared. When you're on the XY axis, of course the Pythagorean theorem still applies. It's a mathematical formula that applies to right triangles. As long as you got a right triangle, you can use it. But it may not be convenient to use A, B, and C because we got so many angles thrown at us, or I'm sorry, variables thrown at us. It might make more sense to use X and Y instead of A and B. So, you know, this would be like A and this would be like B. Why throw in double the variables if you already have X and Y in there? And then the hypotenuse, which you would think a genius might say, hey, I'm going to call the hypotenuse H. No, it's actually called R. Why would it be called R? Well, think unit circle. That's the radius. If this were a circle all the way around and any point can be on that circle, this side would be the radius. So the hypotenuse is called R. It always has been in this context. Oops, I didn't mean to erase that. I don't know why I doodle so much while I talk just to erase it. Probably gets annoying. Sorry about that. Anyway, so that's our scenario. You plot a point on the XY axis. It creates an angle with the positive x-axis, that's standard position, but you make a right triangle out of it, and the 6 trig values for that right triangle are the values you can find. So a squared plus b squared equals c squared becomes x squared plus y squared equals r squared. Exact same formula, just using the variables that are given in the problem instead. Now similarly, we can streamline the 6 trig identities. So sine equals opposite over hypotenuse. Well, the opposite is always going to be y. And the hypotenuse, of course, is called r. So we can call this y over r. Cosecant is just the reciprocal. Actually, you know what? I'm going to do these in red so they stand out a little better. So on this worksheet, when you see sine, you're going to be tempted to think opposite over hypotenuse, and that's good. If you have that memorized, that's excellent. I'm not trying to take that away from you. But it'll go a little faster, and I'm going to refer to it as y over r instead of opposite over hypotenuse. Cosecant is just the reciprocal, so that's r over y. For cosine, that's adjacent over hypotenuse. Well, the adjacent side is always going to be x. So adjacent over hypotenuse is x over r. And then secant is just the reciprocal of that, r over x. Tangent is opposite over adjacent. So remember, opposite is always y, adjacent is x, that's y over x. Cotangent is x over y. Now what's interesting about this is all of this information applies directly to the unit circle. Remember, on the unit circle, the radius equals 1. That's why it's called the unit circle. 1 unit is the radius. Well, if the r is always 1, this becomes y over 1, which is just y. This is x over 1, which is just x. Sorry, x. And if you go back and check your unit circle, every point on the unit circle, x, y, is a cosine comma sine value. So we already know cosine equals x, sine equals y. And then on the unit circle for tangent, you divide the x and the y, or the y by the x. So everything I'm doing here is consistent with the unit circle. The unit circle is just a specific situation where the radius equals 1. Now on this worksheet, there's no guarantee the radius will equal 1, so I'm not going to include this as a permanent part of these notes. I just wanted to show you that this information does tie in with what we've already learned. Whether that makes a big deal to you or not, it's okay if it doesn't. It's just always good to know that what you're learning isn't just some random stuff that someone made up, that it actually all ties together in some way. So there's that for what it's worth. Okay, so let's look at the actual problems. Use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So you're given a point, the diagram is drawn for you, and you're asked to find a trig value. So how are we going to do this? Well, first let's look at what we're asked to find, cosine. From the notes up here, we just explained cosine is x divided by r. And I just realized I forgot something. Hold on. X divided by r. Let me go back up here to these notes. I forgot one thing. The point that's given, x and y, could be positive or negative. That looks like positive on negative, positive or negative, right? You're given any random point. You can have positives and negatives thrown in there, or all positive, or whatever the case may be. The hypotenuse r is always going to be positive, because to find the hypotenuse, you'd use the Pythagorean theorem, or probably this version of it. The last step when you solve one of these, you're going, my dot, dot, dot represents a whole lot of work. The last step to solve for r is to square root both sides. And we always take the positive value because the distance from here to here is a positive value. It's not like an x or a y that the positive or negative sign means left, right, up, down. As a radius, it could point in any direction. So the positive or negative version of it doesn't really apply here. So we just always take the positive version of sine, and the positive version of r, or hypotenuse, and that just sort of makes things work out. So I meant to say that. I should write that down here. Note: r is always positive. And my R doesn't look like an R. I don't know what happens with my handwriting sometimes. R is always positive. Or the mathematical way to say that, R is greater than 1. No, duh, greater than 1. That's dumb. Greater than 0. Positive means greater than 0. Okay, so let's do this. We're asked to find the cosine of theta, and as I pointed out in the notes, cosine is x over r. Well, the x value here is negative 8. So our answer is going to be negative 8 over r, whatever r is. How do I find out what r is? Well, if you like, you can draw the whole triangle. The base of the triangle is negative 8. The height is square root of 17, right? This is a y value. Y is up here, so y is a height. X value is a horizontal value. That's why the negative 8 goes down here. And you can solve for r by doing the Pythagorean theorem. X squared plus y squared equals r squared. So negative 8 squared plus radical 17 squared equals r squared. What is negative 8 squared? Negative 8 squared is positive 64. What is the square root of 17 squared? Well, square roots and squares cancel out, so that's 17. 17 plus 64, let's see, 6 and 1 is 7, 4 and 7 is 11, 11 and 70 is 81, 81 equals r squared, square root both sides, r equals 9. So r is 9, I wrote a 9 right there, because, r goes on the bottom. So what? that should be the answer, -8/9. Let's check number 2. And there it is, -8/9. So you see how this is sort of played. You make a triangle. The point that's given, x, y, x is your horizontal, y is your vertical. You do the Pythagorean theorem to find r if you need to, and then you just write your answer. Now, I sort of stressed if you need to in this problem because tangent is y over x. And if you don't know that, just scroll up, scroll down, check. Tangent is y over x. Well, the y is given and the x is given. So I know my answer is going to be -3/6. The only thing is you can reduce 3 and 6, and then when you have a negative in a fraction, you normally bring it in front of the fraction bar. You don't keep it on top or on bottom. So that reduces to -1/2. -1/2 should be the answer to number 4. And there you see it is. So this one was especially easy because we didn't have to do the Pythagorean theorem like we did in the last problem. And that happens. Sometimes you get easy ones, sometimes you get ones that take work. All right, let's look at number 6. Find the cosecant of theta. So what's cosecant? It's going to be hypotenuse over r, right? Or hypotenuse over, wow. Let me start over. Cosecant is hypotenuse over opposite. We don't want to use those words. We want to use r over y. On this particular worksheet, it's the context that really matters here. So r over y. Well, let's see. If we made a triangle out of this, the y is -√11. The x is -5. The r is unknown. So we're going to have to do the Pythagorean theorem. So -5 squared plus -√11 squared equals r squared. -5 squared is +25. Negative radical 11. Well, the negative's going to, I'm sorry, the square is going to get rid of that negative, and it's going to cancel out the radical, which gives me 11. 25 plus 11 is 36. Square root both sides. R equals 6. The hypotenuse is 6, which means, for my final answer, 6 goes on top, that's the radius, and negative radical 11 goes on the bottom. That's the y. Now I'm going to write that down here where there's a little more room because we do have a little issue here. Remember in mathematics in general, you don't want radicals in the bottoms of fractions. So we're going to rationalize this by multiplying by the square root of 11 over the square root of 11. As I said before, the negative sign I'm just going to pull out in front even with the fraction bar. On top you have 6 times square root of 11. That just stays 6 radical 11. On the bottom, square root of 11 times square root of 11 is square root of 121. And of course, the square root of 121 is 11. And that should be the answer. Now, there are shortcuts to avoid a lot of this work that I'm highlighting right now. So feel free to look into that. Contact me if you want me to explain some shortcuts to you. If you know what you're doing, so be it. I'm not going to make this lecture long by getting on a side note and talking about shortcuts. Anyway, number 6, let me check it. And there it is. Okay, so that's it, right? Well, then we get down here. And we get to problems that do not have the diagram drawn. So am I just giving you busy work where you have to draw your own diagram? Well, you could look at it that way if you want to. I'm going to say no. But I'm going to do number 8 from that perspective. Haskell has given us extra work. We need to draw this now. Furthermore, I don't know where to plot -2 radical 5 comma 4. What is -2 radical 5? You know what? Doesn't matter. It's negative. It's an x value, right? We go x, y. So my point is going to be sort of left and up. So I'm going to put a random dot right there. Do I know for sure that this is 4 units up? Well, I guess if I draw the units, yes. Do I know for sure that that's 2 radical 5? No. It's not drawn to scale. It's just a random dot, but it's in the right quadrant, and that's all that really matters. Connect this to here. The angle we're finding is this angle, technically, but we're just going to focus on the triangle. So the height is 4. The base is -2 radical 5. and we're supposed to find sine. Sine is y over r, right? If you don't have that committed to memory, don't feel bad. It's right there in your notes, y over r. Okay, so the y value is 4, so I know that this is going to be a 4 up here. I don't know what r is, that's unknown, so I'm going to do the Pythagorean theorem. 4 squared plus negative 2 radical 5 squared equals r squared. 4 squared is 16. Negative squared is positive. 2 squared is 4. Radical 5 squared is going to be just a 5, right? Because the square and the square root cancel. So this gives me 16 plus 20 equals r squared. 16 plus 20 is 36. Square root both sides. R equals 6. So my answer is 4/6, which can reduce because they're both even. It reduces down to 2/3. The answer to number 8 is 2/3, and there it is. Now, I said I'm going to present this in a way of saying, yeah, it's just me trying to give you extra work. You have to draw the xy axis, you have to draw the triangle, plot the point, all that stuff. The truth is, you can answer these questions without doing that at all whatsoever. So here, let me demonstrate. First of all, we're supposed to find tangent. Okay, number 10 is going to be ridiculously easy. Yeah, number 12 will be a little more realistic. All right, tangent. What's tangent? Tangent is y over x. Again, if you forget, right there, tangent is y over x. Well, the y value is negative 7, the x value is negative 20. So this is going to be negative 7 over negative 20. 7 and 20 don't reduce, but the negatives will cancel, and you get 7/20. Did I need to draw a triangle for that? No. As long as you know the way points work, x is first, y is second, and as long as you have these ratios in your notes to consult when you need to, or maybe get them memorized, then you don't need a triangle. It's just manipulating numbers at this point. Let me check number 10. Wouldn't it be embarrassing if I was wrong? Okay, there it is, 7/20. But granted, on this one I did not have to do the Pythagorean theorem. So of course it was easier. Let's do number 12. So cosine is adjacent over hypotenuse, so that's going to be x over r. This is the x value, of course that's the y value. So I know my answer is going to be negative 8 over whatever r is. How do I know what r is? Do I need to draw an xy axis, plot a point, make a triangle, label it, and all that stuff? Nah. I know that x squared plus y squared equals r squared. And all I got to do is solve for r, so I know what to plug into my answer. I don't need a picture for that. This is 64. This is 17. 64 and 17, well, we had a problem like this a minute ago. That's 81. Square root both sides. R equals 9. There's my answer. Or more precisely, you put the negative sign out in front. Negative 8/9. So number 12, there's your answer. Now, am I telling you that you have to do your problems like this one? You're not allowed to draw the diagram. You have to just use variables and formulas. No, I'm not telling you that. If your comfort level puts you in a position where you want to draw the xy axis, plot the point, make the triangle, the whole 9 yards, if you thought this was easy to understand and you want to be consistent, then when you do this bottom half of the worksheet, do a picture on each one if you need to. But I do feel that in general, as long as you're not the type who really relies on the visual diagram aspect of it, it's less work and it's generally easier to do it this way. So as I finish my notes, I am going to do it without a diagram, but you may do your homework with a diagram. I'm not making a rule that you have to do it one way or the other. Okay, number 14, cosecant. Cosecant is r over y, but I'm not confident of my memory, so I'm going to check cosecant to make sure. Okay, I got it, r over y. So y is negative square root of 19, so I know that my denominator is going to be negative square root of 19. The numerator is r, so I have to do the Pythagorean theorem. 9 squared plus negative square root of 19 squared equals r squared. 81 plus, okay, square a negative, it turns positive. Square a square root, it cancels, you get 19. 81 plus 19 is 100, and square root both sides r equals 10. Now, negative 10 over square root of 19, you can't have a square root rather in the bottom, so you have to multiply by square root of 19 over square root of 19. That's negative 10 square root of 19 over, all right, what's 19 times 19? I personally don't know, and I don't feel like picking up a calculator, so you know what I'm going to do? I'm just going to call it 19 squared, because 19 times 19 is 19 squared. And a square and a square root cancel each other out anyway, so they're going to be gone. I get negative 10 radical 19 over 19. Let me just make that look more like a 9. And man, if that's not my answer, I'm probably going to have to retire. There it is. All right, next one, I'm going to cheat. 6/5. When we finish number 16, we better get 6/5. In fact, I'm going to write it down here, 6/5. Okay, by the way, any of you who are doing your homework this way, that's bad. Show your work. Okay, this is x, this is y. Secant is r over x. Check your notes if you don't have it memorized. It's r over x. So I know my answer is going to be something over 5. I just don't know what r is. So 5 squared plus radical 11 squared equals r squared. 5 squared is 25. Radical and a square cancel out. That gives me 11. 25 plus 11 is 36. Square root both sides. R equals 6. Put a 6 there, and that's my answer. And yes, of course, it's the answer because we cheated. We knew that was the answer all along. All right, so please do the odds as usual. Check your answers when you are done. Give yourself a grade 0 through 10 points and tell me what that grade is. Show any applicable work. Now notice on number 4, I didn't need to show a ton of work. It wasn't that necessary. There was no Pythagorean theorem to do. So every once in a while, specifically on tangent problems, and if you have any cotangent problems, and it looks like just tangent on this worksheet, there's not going to be a lot of work to show on those. But still, show any work that you do to get credit. Okay, going to stop there. Contact me through text or email or whatever the case may be. Not text, comments, email, whatever the case may be. And otherwise, good luck on this. I'll talk to you another time.